Just have uncovered fossilized nurseries, places where young megalodons were raised, suggesting they gave birth to live young in relatively protected bays, areas that would now be bustling tourist beaches. These juvenile megalodons were already larger than full-grown great whites and were immediately capable of hunting sizable prey. This level of adaptation and dominance from birth suggests that Megalodon was not only a physical powerhouse, but also an evolutionary masterpiece. If it had not gone extinct, today's oceans would be completely different. Marine traffic, fish populations, even human beach culture would be shaped by the need to avoid this living terror. Its disappearance wasn't just the end of a creature. It was the end of an entire chapter in Earth's brutal, beautiful, and dangerous history. The question that haunts scientists and enthusiasts alike is, why did Megalodon disappear? For a predator that ruled for over 20 million years, extinction seems almost unthinkable. But the truth lies in a perfect storm of environmental change and evolutionary pressure. Around 3.6 million years ago, Earth's climate began to cool rapidly, transforming warm, shallow seas into colder, deeper, and less hospitable environments. These changes disrupted the habitats Megalodon depended on, but that was only part of the downfall. At the same time, the ancestors of modern killer whales and smaller, more agile sharks began to thrive. These new predators, while not as massive, were smarter, faster, and able to hunt in coordinated packs. Meanwhile, Megalodon's primary food source, large whales, began to decline in population or migrate to colder waters where Megalodon couldn't follow. Slowly, the monster shark that once feared nothing began to starve, outcompeted and outmaneuvered by the very creatures that still swim our oceans today. Its extinction wasn't the result of one single event, but rather the collapse of an entire world it had mastered for millennia. Though Megalodon vanished millions of years ago, its legacy haunts the deep oceans even today. Modern great white sharks are often called the descendants of Megalodon, though the truth is more complicated. While they share a common ancestor, the massive size and dominance of Megalodon were unique adaptations that did not survive through evolution. Scientists study Megalodon's enormous teeth, jaw structure, and fossilized vertebrae to understand its biology and hunting style, uncovering clues about how it moved and survived in prehistoric seas. Fascinatingly, some marine biologists speculate about the possibility of undiscovered giant sharks lurking in the deep ocean trenches, areas too remote and hostile for humans to explore fully. These theories fuel both scientific curiosity and popular imagination, inspiring documentaries, movies, and endless speculation. The truth is, while no credible evidence suggests Megalodon still swims today, its shadow shapes how we think about the ocean's mysteries and the creatures that might still lie hidden beneath the waves. Megalodon's impact on marine ecosystems extended far beyond its sheer size and hunting prowess. It played a crucial role in shaping the balance of life in the oceans. By preying on large marine mammals, Megalodon controlled populations of whales and seals, preventing any one species from dominating the ecosystem. This predator-prey dynamic fostered biodiversity and maintained the health of ocean habitats. Without Megalodon's presence, some species might have overpopulated, leading to resource depletion and collapse of marine food webs. Moreover, its existence influenced evolutionary paths. Prey animals developed faster swimming speeds, thicker blubber layers, and complex social behaviors to evade such a relentless hunter. The ripple effects of Megalodon's reign likely influenced the evolution of modern marine mammals, shaping the oceanic world we know today. Understanding this ancient predator helps us appreciate how interconnected and delicate marine ecosystems really are, and how the loss of a single apex predator can reshape the natural order. One of the most haunting questions about Megalodon is whether it could return, or if by some miracle it still survives in the uncharted depths of our oceans. Over the years, mysterious sightings, unexplained sonar readings, and alleged giant teeth discoveries have sparked rumors and conspiracy theories among marine enthusiasts and cryptozoologists alike. While scientific consensus strongly denies the possibility of Megalodon's survival, these stories tap into a deep human fascination with the unknown and the terrifying. The oceans cover over 70% of our planet and remain vastly unexplored, leaving room for legends and myths to flourish. The idea of an ancient giant lurking beneath the waves ignites the imagination and reminds us how little we truly know about the deep sea. Whether real or imagined, Megalodon symbolizes the ultimate mystery of the ocean, powerful, primal, and lurking just out of sight. The fossilized teeth of Megalodon have captivated scientists and collectors alike, serving as tangible links to a world long vanished beneath the waves. These massive teeth, some over 7 inches in length, are not only reminders of the creature's formidable size, but also crucial tools for understanding its biology and behavior. By studying the wear patterns and microscopic scratches on these teeth, researchers can infer Megalodon's diet, hunting methods, and even how often it replaced its teeth. Unlike humans, sharks continuously shed and regrow teeth throughout their lives, and Megalodon likely went through thousands of teeth replacements. These fossils are found worldwide, from the coasts of North and South America to Europe and Africa, painting a picture of a global predator that once ruled all warm oceans. Each tooth tells a story, a snapshot of a moment in a prehistoric ocean where Megalodon ruled supreme, reminding us of a time when nature's power was on a scale we can so barely imagine. Megalodon's sheer size and power have inspired countless works of fiction, from blockbuster movies to novels and documentaries, shaping how we imagine prehistoric seas. Yet, beyond the thrill and spectacle, these portrayals often spark real scientific curiosity and interest in paleontology and marine biology. Megalodon stands as a symbol of nature's extremes, how evolution can produce creatures both magnificent and terrifying. Its extinction reminds us that no matter how dominant a species becomes, the forces of change, climate shifts, competition, and habitat loss can bring even the mightiest down. Today, as we face our own environmental challenges, Megalodon's story serves as a powerful reminder of nature's fragility and resilience. Understanding this ancient predator helps us appreciate the delicate balance of life on Earth and encourages us to protect the oceans and their inhabitants before more secrets vanish forever. The ocean depths where Megalodon once ruled remain, some of the least explored places on Earth, harboring countless mysteries about life beneath the waves. Scientists today use advanced technology like deep-sea submersibles, sonar mapping, and remote-operated vehicles to probe these shadowy realms, searching for clues about ancient and modern marine life. The discovery of species thought extinct or entirely new to science in these depths reminds us how little we know. If Megalodon were alive today, surviving in these dark ocean trenches would be incredibly challenging given its massive size and need for abundant prey. However, the ongoing exploration of deep seas continuously reshapes our understanding of oceanic ecosystems and inspires new questions about the creatures that might still lurk where sunlight never reaches. Each expedition peels back layers of mystery, but Megalodon's legacy ensures the ocean will forever be a place of awe, danger, and wonder. Megalodon's reign in the prehistoric oceans was not just about size and strength. It was a complex tale of adaptation, survival, and ecological dominance that still fascinates scientists today. This giant shark evolved over millions of years, adapting to changing climates, shifting sea levels, and the rise and fall of its prey species. It developed a body built for power and speed, with massive, robust jaws and teeth designed to slice through the toughest hides and bones. The evolutionary story of Megalodon reflects a perfect balance between predator and environment, where every aspect of its physiology was honed to maximize hunting efficiency in warm, coastal waters rich with marine mammals. But this perfection also came with vulnerabilities. When Earth's climate began cooling during the Pliocene epoch and the seas changed, Megalodon's specialized nature became a disadvantage. Its large size demanded vast amounts of food, and as whale populations dwindled or migrated, Megalodon struggled to find enough prey. Meanwhile, smaller, more adaptable predators began to fill ecological niches Megalodon left vacant. This gradual shift led to its extinction, a dramatic turning point in marine history that reshaped ocean ecosystems forever. Today, by studying Megalodon's fossils and comparing them with modern sharks, scientists uncover lessons about evolution, extinction, and the delicate balance that sustains life in our oceans. This deep dive into Megalodon's evolutionary journey reveals a creature as fascinating as it is fearsome, an ancient titan whose story echoes through time and reminds us of nature's power to create, adapt, and ultimately reclaim. Megalodon's extinction created a ripple effect that dramatically altered the oceanic food chain and allowed new species to flourish in its absence. With the disappearance of such a dominant apex predator, the marine ecosystem underwent significant restructuring. Smaller sharks and predatory whales, like the ancestors of today's orcas and great whites, began to occupy the top spots in the food chain, developing hunting strategies that emphasized speed, intelligence, and social cooperation rather than sheer size. This shift not only diversified predator species but also impacted prey populations, allowing certain whale species to expand and evolve in new directions. The absence of Megalodon opened ecological niches that reshaped the marine environment, demonstrating how the loss of one species can trigger a cascade of evolutionary changes. Studying these transitions provides valuable insight into how ecosystems respond to the loss of key predators, a lesson that remains crucial today as we witness rapid changes in marine biodiversity due to human activity and climate change. Megalodon's story thus extends beyond the past, offering a cautionary tale about the delicate balance of life in the ocean and the far-reaching consequences when it is disrupted. The sheer size and power of Megalodon meant it had few, if any, natural enemies. However, it wasn't invincible. Scientists believe that young megalodons faced threats from other large predators, including adult members of their own species, making juvenile survival a fierce battle. Competition for food and territory may have driven aggressive encounters that shaped Megalodon's social behavior, if it had any. While much about its behavior remains speculative, some paleontologists suggest Megalodon may have exhibited solitary hunting like modern great whites, while others think it could have hunted in small groups to take down massive prey. The fossil evidence hints at a brutal life, where survival was never guaranteed even for the mightiest. These battles for dominance, survival, and resources reflect a harsh prehistoric world governed by power and adaptation. Understanding these dynamics helps us glimpse the life of a creature that dominated oceans, but was also part of a complex, competitive ecosystem where only the strongest and smartest thrived. Megalodon's enormous size was supported by a unique physiology adapted to sustain its power and energy needs. Unlike many sharks today that rely on warm blood from their environment, some evidence suggests Megalodon may have had a form of regional endothermy, meaning it could regulate the temperature of certain body parts, like its swimming muscles and brain, to maintain high performance in cooler waters. This adaptation would have given it an edge as a predator, allowing it to hunt efficiently across a range of ocean temperatures and depths. Its massive, streamlined body was built for bursts of speed and strength, enabling it to ambush prey quickly and powerfully. Scientists have also studied the growth rings in fossilized vertebrae to estimate its lifespan, which may have been up to 70 years. Impressive for a shark. This combination of physical traits made Megalodon an apex predator perfectly tuned to its environment, balancing speed, strength, and endurance. And such adaptations are a testament to the incredible evolutionary journey that crafted one of the ocean's most formidable hunters. Megalodon's hunting strategy was as brutal as it was efficient, relying on sheer power and precision to dominate its prey. Unlike many modern sharks that chase down smaller fish, Megalodon targeted large marine mammals, primarily whales, which made up the bulk of its diet. It used a surprise attack approach, stealthily approaching from below or behind before unleashing a devastating bite aimed at the most vulnerable parts of its prey, such as the spine or chest, to immobilize or kill quickly. Its enormous jaws could clamp down with such force that it could sever whale vertebrae in a single bite, causing fatal damage. After the initial attack, Megalodon would often retreat, allowing the prey to weaken from blood loss before circling back to finish the kill. This hunting method was not only effective, but also minimized risk of injury to the predator. Additionally, evidence from fossilized bite marks suggests that Megalodon might have engaged in territorial battles with other megalodons or large predators, indicating a fiercely competitive lifestyle. Understanding this hunting behavior paints a vivid picture of a relentless marine titan that ruled the seas with unmatched ferocity. Megalodon's extinction left a lasting impact on human culture, inspiring myths, legends, and fascination with monstrous sea creatures throughout history. Although it disappeared millions of years before humans existed, its massive fossilized teeth have been found and admired by people for centuries, often mistaken for dragon or giant serpent teeth in ancient folklore. These finds sparked stories of sea monsters lurking beneath the waves, shaping maritime legends around the world. In modern times, Megalodon has become a symbol of nature's awe-inspiring power, featuring prominently in movies, books, and documentaries that capture the imagination of millions. Its story reminds us of a time when Earth was home to giants, and the ocean was a realm of mystery and danger. By studying Megalodon, we not only unlock secrets of the past, but also tap into a primal fascination with the unknown, a reminder that even in today's advanced world, the ocean still holds terrifying secrets waiting to be discovered. Travel back over 20 million years, to a time when the oceans teemed with strange and powerful life, and the most feared of all was just beginning to rise, Megalodon. This giant didn't appear out of nowhere. It evolved from a lineage of ancient mackerel sharks during the early Miocene epoch. Its ancestors were already apex predators, but Megalodon took evolution to the extreme. Scientists believe it first emerged around 23 million years ago, growing larger and more powerful with each generation. Fossil records show its teeth evolving into broad, serrated tools built for slicing through the flesh and bone of giant prey. This was the beginning of one of Earth's greatest marine predators, a creature shaped by time, pressure, and the relentless drive to dominate. Let's dive deeper into how this behemoth first took form in prehistoric seas. Imagine the prehistoric, seas where early whales swam freely, until a new threat emerged from the deep. As Megalodon continued to evolve through the Miocene epoch, it rapidly adapted to become the dominant predator of its age. Its enormous size, sometimes exceeding 60 feet, didn't just appear overnight. Fossil evidence suggests that as prey animals like baleen whales grew larger, Megalodon's lineage responded in kind, through natural selection, evolving into a true leviathan. These early megalodons had already developed the wide, triangular, serrated teeth that would become their signature weapon, perfectly designed for tearing through thick whale flesh and bone. The oceans of that time were rich and biodiverse, but competition was fierce. Megalodon's rise marked the start of a new marine hierarchy, where no creature was safe from the jaws of this unstoppable hunter. As the Miocene epoch progressed, Megalodon carved out its reign across the globe's warm, shallow seas, becoming a symbol of evolutionary triumph. Fossils of its massive teeth have been discovered on every continent except Antarctica, proving that this predator was truly cosmopolitan. But what allowed it to spread so widely? The answer lies in the geography of the time. Vast, open seaways connected distant oceans, and marine life flourished in abundance. Megalodon followed its prey, whales, dolphins, and giant fish, across these ancient aquatic highways, establishing itself as the ocean's undisputed apex predator. Its migration wasn't random. It was driven by the seasonal movement of prey and the temperature preferences of a warm-blooded predator. Each generation ventured farther, growing larger and stronger, shaping a global dynasty that would remain unchallenged for millions of years. During the heart of the Miocene epoch, between roughly 15 to 10 million years ago, Megalodon reached the peak of its evolutionary development, establishing itself as the most dominant marine predator Earth had ever seen. This was a golden age of cetacean diversity. Whales were evolving into a wide variety of forms and sizes, from swift raptorial species to immense filter feeders, and Megalodon thrived in this environment of abundance. Its body was a masterpiece of design sculpted by evolutionary pressure, a torpedo-shaped frame that allowed for efficient long-distance travel, a powerful crescent-shaped tail for bursts of speed, and jaw muscles capable of delivering the strongest known bite in the animal kingdom. Its teeth, each the size of a human hand, were wide, triangular, and finely serrated, engineered not just to bite, but to shear through bone, flesh, and cartilage with terrifying ease. These formidable tools allowed it to target the most energy-rich prey available: young whales, injured adults, large dolphins, and even other sharks. It likely used ambush tactics, attacking from below or behind to sever spinal cords, crush rib cages, or inflict fatal wounds before consuming its prey in chunks. Despite being a cold-blooded creature like modern sharks, there is speculation that Megalodon may have had some form of regional endothermy, a primitive ability to regulate body temperature in key areas like the brain and muscles, allowing it to hunt in cooler waters and expand its range even further. Fossil records indicate Megalodon roamed oceans from the coast of present-day Japan to the Atlantic shores of Europe, from the warm Pacific corridors of Central America down to the coastlines of Africa and Oceania. Its presence was global, and its reign was uncontested. The structure of marine ecosystems revolved around its dominance. Prey species had to evolve strategies to avoid detection, change migratory routes, or develop stronger social structures. For protection, even scavengers such as early species of orcas and large birds likely followed Megalodon for scraps. Its dominance shaped not just the biological landscape, but also the behavioral evolution of other marine life. Unlike modern great white sharks, which are typically solitary, Megalodon may have exhibited different social behaviors, perhaps temporary associations during feeding, mating, or migratory events, though the fossil record remains silent on this due to the rarity of preserved cartilage and soft tissue. Still, the sheer number of teeth found in clustered areas suggests that feeding frenzies or regional migrations were possible, if not common. Its size was both a blessing and a curse. While it allowed Megalodon to overpower nearly any opponent, it also required massive caloric intake, and thus it was wholly dependent on the health and abundance of prey populations. This apex role made it vulnerable to any long-term ecological changes, but during the mid to late Miocene, the balance remained in its favor. Ocean temperatures were warmer, sea levels higher, and prey populations abundant. These conditions created an optimal environment for Megalodon to thrive, reproduce, and dominate. Juveniles may have grown in shallow, protected nursery areas. Fossilized teeth from very young individuals have been found in what would have been warm, coastal bays, providing safety from other predators and plentiful food. Growth was rapid. Studies of vertebral growth rings suggest that Megalodon could reach nearly 30 feet within a few years, an evolutionary necessity in a sea where size determined survival. Its reproductive strategy may have included internal fertilization and live birth, with large, well-developed pups that had a better chance of surviving into adulthood. Even in youth, a Megalodon would have been larger than most modern sharks, already occupying a mid-level predator role in the ocean's food web. While adult Megalodons ruled the open seas, juveniles likely stayed closer to shore, feeding on rays, fish, and smaller marine mammals. In this way, the species occupied multiple ecological niches across its lifespan. This adaptability contributed to its long reign and global expansion. From an evolutionary perspective, Megalodon was a pinnacle, an animal perfectly suited to its world. But Earth was changing. Tectonic shifts began to reshape continents and restrict ocean passages. The closing of the Central American Seaway, for instance, started to divide populations of marine life between the Pacific and Atlantic, slowly altering migratory routes and limiting genetic exchange. Cooler global temperatures began to lower sea levels, reducing the warm, shallow habitats Megalodon preferred. Prey species, especially the large whales Megalodon depended on, began evolving differently in response to these changes. Some became too fast or too scarce. Others moved to colder regions where Megalodon's warm water preference became a limitation. While these changes were subtle at first, over millennia they began to tip the balance of survival. For the moment, though Megalodon continued its undisputed reign, the very image of raw evolutionary power, an apex predator whose life cycle, biology, and behavior had shaped oceanic ecosystems for millions of years. In this window of time, the giant shark was not a monster but a masterwork of natural history, a creature whose every tooth and muscle told the story of adaptation, dominance, and the brutal beauty of life at the top of the food chain. As the Miocene epoch transitioned into the Pliocene around 5.3 million years ago, the empire of Megalodon began to face its first real threats, not from rivals in the sea, but from the changing planet itself. Earth's climate began to cool, steadily, a trend that would continue into the ice ages, and this shift had massive consequences for marine ecosystems. Sea levels dropped as glaciers expanded, and with them, many of the warm, shallow coastal nurseries that Megalodon relied upon for reproduction vanished. These nursery zones had been critical to the life cycle of this apex predator, offering young Megalodons safe spaces to grow away from the open ocean dangers. Without these crucial environments, juvenile survival rates may have plummeted. Simultaneously, the abundance and migration patterns of prey species, especially baleen whales, began to change. Whales started moving toward colder, polar regions in search of nutrient-rich waters, areas where Megalodon may have struggled to follow due to its preference for warm temperatures. This geographic shift in food sources gradually pushed Megalodon into more confined ranges, or forced it to spend more energy traveling between distant feeding grounds. While once a global predator, Megalodon was now becoming increasingly restricted by both geography and biology. Fossil distribution supports this, with younger Megalodon teeth being found less frequently and in fewer locations compared to their Miocene-era abundance. But the story of Megalodon's decline is not simply one of climate and habitat, it's also one of rising competition. During the Pliocene, a new kind of predator began to emerge, the ancestors of modern orcas and other highly intelligent, fast, and cooperative marine mammals. While Megalodon relied on brute force and solitary ambush tactics, these newcomers used speed, communication, and pack hunting strategies to challenge the old king of the sea. Fossil records show that some species of ancient whales and predatory dolphins developed defensive formations much like modern whales protecting calves from orca attacks, suggesting that they were adapting to threats like Megalodon. But these adaptations also made them more resilient against Megalodon's hunting strategies, forcing it to expend more energy for each successful kill. Over time, this energy imbalance may have begun to wear on the species. Another key factor in Megalodon's decline lies in evolutionary specialization. While Megalodon had evolved to be the perfect predator of large marine mammals in warm waters, it was also, by that very perfection, less adaptable to change. In contrast, smaller predators like great white sharks and orcas were more flexible. They could hunt a wider variety of prey, survive in more varied temperatures, and reproduce faster. This biological versatility gave them an evolutionary edge, as environmental conditions grew less predictable. Megalodon's slow reproduction rate, large food requirements, and narrow ecological niche made it extremely vulnerable to extinction once conditions began to shift even slightly. And unlike many smaller species that could adapt or migrate, Megalodon had nowhere left to go. Despite its power, it could not overcome the cold, could not chase prey into icy waters, and could not outcompete faster, smarter predators that worked in groups. It was a titan built for a world that no longer existed. And as oceanic corridors narrowed and climates cooled, Megalodon began to vanish from the fossil record. The youngest confirmed Megalodon fossils date to around 3.6 million years ago, marking the probable window of its extinction. Though the exact cause of its disappearance remains debated, whether a sudden collapse in prey populations, intense competition, or an inability to adapt to rapid environmental change, it is widely agreed among scientists that Megalodon's extinction was a multifaceted collapse. It wasn't one single event, but a series of interconnected ecological shifts that slowly, but surely, eroded the foundation of its dominance. There is also compelling evidence that a new wave of whale species evolved to be faster, leaner, and better suited to evading giant predators. The massive, slow-moving whales of the Miocene that had made up much of Megalodon's diet were replaced by faster rorquals like the ancestors of today's humpback and blue whales. These agile giants, combined with the rise of coordinated hunting, predators like orcas completely rewrote the rules of the marine food web. Megalodon found itself increasingly out of sync with the new ocean dynamic. And unlike land-based creatures whose fossilized bones might tell a clearer story, sharks leave behind mostly teeth, strong, enduring, but often isolated clues in the fossil record. From these remnants, paleontologists piece together a picture of decline. Teeth become rarer, smaller, and more geographically restricted. Eventually, they disappear altogether. And so, after more than 20 million years at the top, Megalodon, one of the most magnificent predators to ever live, vanished from the Earth's oceans, leaving behind only fragments of its story buried in stone. The rise and fall of Megalodon is not just the tale of a prehistoric beast. It is the chronicle of how evolution shapes and ends empires. In every tooth, every fossilized nursery ground, and every scarred whalebone lies the memory of an apex predator undone not by a rival's fang but by the quiet, unstoppable forces of planetary change. After Megalodon's disappearance from the fossil record around 3.6 million years ago, a deep and persistent silence settled over the oceans. A silence that would later give rise to one of the greatest mysteries in marine paleontology. The vanishing of the ocean's most powerful predator did not go unnoticed by nature, but it would be millions of years before humans, sifting through ancient sediments, would realize what had been lost. The puzzle of Megalodon's extinction remains one of the most debated topics in paleobiology, with scientists working tirelessly to piece together the circumstances that led to its downfall. In the centuries following the discovery of the first fossilized Megalodon tooth, a wide array of theories has been proposed, each one adding a new layer of complexity to an already enigmatic disappearance. One major theory posits that the rise of modern baleen whales, which began migrating to colder, more polar regions, effectively starved Megalodon out of its primary food sources. The predator, adapted for warm, shallow seas, couldn't follow these whales into icy waters. This thermal limitation, combined with the collapse of its traditional prey base, may have set off a slow but inevitable decline. Yet other researchers argue that Megalodon's extinction was not just about food or temperature, it was about competition. Around the same time Megalodon fossils became scarcer, the fossil record shows a rise in smaller but more agile predators like the early great white shark, Carcharodon carcharias, as well as the appearance of large social marine mammals such as Orcanis orca. Unlike Megalodon, which was likely a solitary hunter, these new predators could adapt quickly to environmental change, hunt in groups, and expand their dietary options when needed. This versatility gave them an edge that the hyper-specialized Megalodon simply couldn't match. But not all scientists agree on the timeline. Some earlier studies had placed Megalodon's extinction as recently as 2.6 million years ago, using teeth found in younger sediments to support their case. However, more refined dating techniques have since revised that estimate, suggesting that many of those younger teeth had been reworked, moved by geological processes into newer layers from older deposits. These findings pushed the extinction window further back, narrowing the period during which Megalodon's final populations may have lived. Another fascinating avenue of research centers around Megalodon's reproduction. Unlike smaller sharks, Megalodon likely had very few offspring in each reproductive cycle, but those pups were enormous. Some estimates suggest they were already 6 to 10 feet long at birth. This strategy of investing heavily in a few large, well-developed offspring worked well during times of abundance, but it may have backfired in the Pliocene. As prey became scarce and coastal nursery grounds vanished due to dropping sea levels, even these large juveniles may have struggled to find food or suitable shelter. Without a high reproductive rate to offset these pressures, the species would have faced generational collapse. Adding to the mystery is the fact that Megalodon teeth have been found scattered across diverse environments, from the coasts of Europe to the depths of the Pacific, from riverbeds in the Americas to desert plateaus that once lay underwater. This broad distribution suggests not only the species' vast range, but also the complexity of studying it. Many of these discoveries were made before the development of modern stratigraphy, and without precise dating methods, early interpretations of Megalodon's history were often contradictory. Even today, some amateur fossil hunters claim to find young Megalodon teeth, reigniting fringe theories that the shark still survives in the ocean's unexplored depths. These claims, however, are unsupported by evidence, No living specimen, carcass, or even sonar trace has ever indicated that Megalodon still swims today. Yet the idea lingers, fueled by a mix of awe, nostalgia, and the innate human desire to believe that such a magnificent creature might still defy extinction. Scientific consensus, however, rests on cold data, radiometric dating, isotope analysis, and comparisons with co-occurring marine life all point to a definitive end for Megalodon sometime in the mid-Pliocene. But extinction, in the scientific sense, is rarely a sudden event. It's often a drawn-out process, one that can span thousands of years with small isolated populations surviving long after the species has effectively disappeared from most of its former range. It's entirely possible that the last megalodons were born in marginal seas hunting limited prey, gradually growing weaker and rarer until the final individuals faded into evolutionary silence. And yet, even in extinction, Megalodon continues to influence the scientific imagination. Its teeth, among the most frequently found and easily recognized marine fossils, have become symbols of prehistoric power. Museums display them like holy relics, and schoolchildren gasp at their size, their weight, the serrated edges that once carved through whalebone. For paleontologists, each tooth is a data point, a fragment of a larger narrative that continues to evolve with each new discovery. Through the lens of isotopic chemistry, scientists can now determine where a tooth-bearing shark lived, what it ate, and even how ocean temperatures fluctuated during its life. These tools have turned Megalodon from a legend into a living data stream, one that tells a story far more complex than any single extinction event. The narrative emerging is not just about one species, but about the interconnectedness of life and the delicate balance that sustains it. Megalodon's downfall is a case study in ecological vulnerability, a cautionary tale for our modern world, where apex predators on land and sea face their own forms of environmental disruption. Just as Megalodon could not outswim climate change, habitat loss, and food scarcity, so too do today's great predators, tigers, sharks, orcas, struggle to adapt to a rapidly shifting world. The legacy of Megalodon is thus not only etched into stone, but into the very principles of ecology, evolution, and extinction. Its story is far from over, and the quest to understand its life and demise continues to drive scientific exploration into the deepest past. Though Megalodon vanished millions of years ago, its ghost has never truly left the oceans or the human imagination. Long after the last of its enormous jaws snapped shut on a doomed whale, the scattered evidence of its reign lay buried in ancient seabeds, waiting for the earth itself to shift, erode, and reveal the relics of its legacy. When humans began dredging rivers, quarrying limestone, and digging into coastal cliffs, they unearthed teeth unlike anything else in the animal kingdom, massive, triangular, and serrated like ancient blades designed to rip through giants. These fossils, often found hundreds of miles inland where oceans once surged, sparked both awe and confusion. Early scholars mistook them for the petrified tongues of dragons or the claws of monstrous birds. It wasn't until the scientific revolution, when comparative anatomy took root, that these teeth were correctly identified as the remains of a giant prehistoric shark, one that dwarfed any living species. And so began the modern myth of Megalodon. Unlike dinosaurs, whose full skeletons give us a clearer picture of form, sharks leave behind mostly cartilage, which decomposes over time. Only their teeth and a few vertebrae endure the ages. This limited fossil record has created both a scientific challenge and a mystery, inviting generations of paleontologists to extrapolate an entire creature from its teeth alone. The largest of these teeth, some exceeding 7 inches, suggested an animal that could have reached up to 60 feet in length, though estimates vary widely. Its bite force, reconstructed using digital models and biomechanical simulations, may have exceeded 180,000 newtons, strong enough to crush the bones of even the largest whales. Such power, combined with the massive feeding scars found on fossilized whale skeletons, painted a picture of a relentless predator ruling a blue empire for millions of years. Yet the scarcity of complete Megalodon remains has also allowed speculation and fantasy to fester. Popular media, from novels and movies to cryptid folklore, have imagined the shark surviving in the unexplored abysses of our oceans, evading detection while preying on colossal squid and deep-diving whales. Shows and documentaries, some intended more for entertainment than science, have perpetuated the idea that Megalodon might still exist in the Mariana Trench or beneath Antarctic shelves. These tales, while thrilling, are firmly refuted by science. The ocean is vast, but modern sonar, submersibles, and global tracking of marine ecosystems have never uncovered any evidence of a surviving Megalodon population. A creature of such size and hunger could not remain hidden without leaving behind carcasses, tooth marks, or disrupted food webs. Still, the myth persists because it taps into a primal human fear that something massive, ancient, and unstoppable might still lurk in the dark. Meanwhile, the actual science continues to evolve. Fossilized megalodon teeth are now among the most studied paleontological objects in the world. They have been found on every continent except Antarctica, suggesting a once global distribution across warm waters. The enamel of these teeth preserves isotopic signatures that allow scientists to analyze the animal's diet, migratory patterns, and even the temperature of the water it lived in. For example, studies of oxygen isotopes reveal that Megalodon preferred waters between 12 degrees and 27 degrees, further reinforcing the theory that global cooling played a pivotal role in its extinction. Some teeth show signs of repeated breakage and regrowth, suggesting an aggressive feeding behavior and a high metabolic demand. Others contain traces of manganese nodules, indicating they lay on the ocean floor for millions of years before fossilization. With every new discovery, the scientific portrait of Megalodon grows sharper, not just as a monster but as a finely tuned ecological machine. Beyond the labs and museums, Megalodon has carved a niche in education and culture. It has become a gateway for young students into the world of paleontology, drawing curiosity with size and danger, then redirecting that awe toward evidence-based science. Fossil hunting groups regularly gather along ancient coastlines, especially in places like South Carolina, Peru, and Morocco, hoping to find a glint of enamel in the sediment. Museums display replica jaws large enough for visitors to stand inside, allowing a first-hand glimpse of nature's scale during the Miocene. In ETB, universities' courses on marine evolution often begin with the question, how did Megalodon rule and why did it fall? Because the deeper we investigate Megalodon, the more it tells us about oceanic ecosystems, evolutionary bottlenecks, and the fragility of apex predators in times of environmental change. Its extinction teaches us that no species, no matter how powerful, is immune to the pressures of a shifting planet. Yet even as science explains Megalodon's past, the shark remains an icon of what once was, a living nightmare sculpted by evolution, erased by time, and resurrected through fossil clues. It represents the pinnacle of shark evolution, the might of a creature perfectly adapted to its world, and the reminder that such worlds are not permanent. The sediment that holds its teeth is more than dirt and rock. It is a geological diary, a testament to a species that once held dominion over all it surveyed beneath the waves. And as we continue to dig, to classify, to hypothesize, the story of Megalodon only grows deeper, more intricate, and more compelling. It is a history not just of one animal but of oceans themselves, of Earth's changing moods, and of the eternal dance between predator and prey. The end of Megalodon's reign did not merely leave behind silence in the seas. It created a vacuum, an ecological crater that rippled through the marine food web for millennia. When such a dominant apex predator disappears, its absence is felt in every level of the oceanic ecosystem. Whales, once prey, grew larger and more populous, their evolutionary trajectory no longer constrained by constant predation. New marine predators rose to fill the void. Great white sharks evolved into swift, agile hunters. Orcas developed complex, social hunting behaviors. And marine reptiles began to reclaim niches long held by the giant shark. But Megalodon's extinction also left behind something more permanent. A window into Earth's deep past, and a cautionary tale written in bone and stone. With every discovery of a fossilized tooth, we glimpse not just the anatomy of a predator, but the volatile nature of evolution itself. The fossil record tells us that no species, no matter how mighty, is immune to environmental upheaval. The very rise of Megalodon, from a smaller shark in the Otodontus lineage to a global superpredator, was fueled by an era of warm oceans, rich in prey and coastal nursery zones. Yet, when the Earth cooled, currents shifted, and prey vanished, those same advantages turned into weaknesses. The evolutionary strategy of birthing large, few offspring required stable conditions. When those crumbled, so too did Megalodon's future. Its story is an evolutionary crescendo followed by silence. And this silence has spoken volumes. It has taught scientists how ecosystems respond to the loss of a keystone species, and it has provided insight into the fragility of apex dominance. In many ways, Megalodon is a lens through which we study extinction dynamics and adaptive failure. Its disappearance was not caused by a single catastrophe like an asteroid, but rather by a perfect storm of gradual stressors: climate change, prey redistribution, competition, and perhaps even disease. This makes it all the more relevant in our time, as modern oceans face similar stressors. Today, great white sharks are overfished, whales contend with ship strikes and ocean noise, and warming seas threaten coral reefs and fish nurseries. The extinction of Megalodon is no longer just a prehistoric curiosity, it's a mirror. But Megalodon also offers more than warnings. It provides inspiration. Its image has become iconic in science fiction, art, and even conservation branding. It embodies the awe of prehistory, the drama of deep time. From giant replicas in museums to CGI-infested blockbuster films, Megalodon has transcended its fossilized reality to become a symbol of what nature can produce and take away. In education, its sheer scale and mystery captivate students, leading them to question, explore, and dig deeper into natural history. Its teeth, easily recognizable and surprisingly common, act as gateways into paleontology for countless amateur fossil hunters. Unlike the bones of dinosaurs often locked away in remote desert beds, Megalodon's legacy washes ashore in riverbanks, gravel pits, and tidal cliffs. Its history is accessible, democratic in its reach. Even the scientific debates around its size and classification have invigorated academic discourse. Was it truly part of the modern great white lineage or a member of a now-lost megatooth branch? This simple taxonomic question has generated decades of research, engaging minds across continents, and the pursuit is far from over. New dating methods, AI-powered reconstructions, and marine simulations are opening fresh chapters in Megalodon's story. Even now, paleontologists are revisiting old fossil sites with new tools, scanning teeth for microscopic growth rings, analyzing isotopes for dietary shifts, and examining associated fauna to recreate the vanished ecosystems Megalodon once patrolled. Each study brings us closer to understanding not just how Megalodon lived, but how life itself adapts, flourishes, and ends. Perhaps the most enduring part of Megalodon's story is its emotional resonance. It is a creature that never met humans, yet it dominates our imagination. We are drawn to its scale, its mystery, its dominion over the sea. And in that fascination lies something universal, a longing to connect with the vast, untamed history of our planet. Megalodon reminds us that Earth was once governed by beings we can barely comprehend, that life has rewritten itself countless times, and that the world we inhabit is only the latest draft in an ancient, ongoing script. The sea, with all its darkness and depth, still holds echoes of that giant predator, not in reality but in memory, in the weight of its teeth, in the sedimentary stories of long-dead oceans, and in the silent awe of those who study its trace. As the fossil record gradually closes the chapter on Megalodon, the legend only grows louder. It roars not from the deep, but from our own curiosity, daring us to imagine a world more ferocious, more primal, and more breathtaking than the one we know. That is Megalodon's true legacy, not just as a shark, but as a symbol of evolution's grandeur, extinction's inevitability, and science's relentless pursuit of the truth. In its rise and fall, we see the very rhythm of life on Earth. And while its body may have dissolved into ancient seas, its story remains indelible, etched into stone, science, and the collective imagination of humankind.